Climate change can no longer be viewed as just a theory. Temperatures and sea levels are rising across the world as we continue to increase atmospheric carbon dioxide levels. Understanding how these changes will affect large-scale weather features, such as tropical cyclones, is a mystery that scientists aim to solve. In order to predict future tropical cyclone activity, it is crucial to understand the patterns and cycles of previous activity. The observational record of tropical cyclone activity is very short, so a method of gathering information on past geologic periods is necessary. This method is known as paleotempestology. Paleotempestology involves using data collected from soil, ocean, and cave deposits in order to gauge the level of tropical cyclone activity at a specific location. Isotopes produced from tropical cyclone rainfall can be used as tracers to account for activity. Another application of paleotempestology consists of using computer models to simulate tropical cyclone activity during prehistoric climates. Using paleotempestology, specifically isotope data, scientists have been able to construct a high-resolution record of previous tropical cyclone cycles and have been able to identify tropical cyclones separated by as little as 2 weeks. Also, researchers were able to recreate the climate of the last glacial maximum, which occurred about 20,000 years ago. In this modeled climate, they were able to analyze tropical cyclone activity in a situation where temperatures were much cooler than those of today. Intriguingly, the model showed an increased amount of tropical cyclones. As it turns out, there are many tropical cyclone genesis factors that are more favorable in a cooler climate. So if there are more tropical cyclones in a cooler climate, would that mean that there will be less tropical cyclones in a warmer one? In a simulation where researchers doubled the CO2 present in the atmosphere, tropical cyclones were shown to decrease by around 20%, while the intensity of these storms increased by about 3%. Other tropical cyclone characteristics, such as precipitation and size, also increased, while average lifetime and track length decreased. Researchers have noted that the tropical cyclone activity has decreased dramatically over the past 100 years compared to the previous 1,500 years. This also coincides with the beginning of the Industrial Revolution, when humans began emitting CO2 and other pollutants into the atmosphere. This then raises the question, is climate change responsible for the dramatic decrease in recent tropical cyclone activity? The answer to this question is maybe. There are many other factors that can affect the tropical cyclone cycle, and more research must be done in this area before definite conclusions can be made. But the following appear to be true. Tropical cyclone activity will continue decreasing, and also, the tropical cyclones that do form will be stronger in both intensity and flooding potential, but will likely have shorter lifespans. The future of tropical cyclones remains uncertain, but further research in identifying the levels of past activity through paleotempestology is critical to understanding how tropical cyclones will behave in an increasingly warm world. For Up in the Air, I'm Shane Kearns.